A system of four forces acting on a body is shown in figure. Determine the resultant. Here there are four forces are acting on a body at point O, and question is to find out the resultant of this system of forces. So all these forces are inclined forces. If you see here, this force, 100 Newton force making an angle 40 with this vertical line, y-axis, and 50 Newton force making an angle 60 degree with this x-axis. So we can resolve them into x component and y component. But here we don't know the angles, but these are given. So for this, what I will do is, now we can take this angle as theta 1. So angle as theta 1, then here also this, it will become theta 1. From geometry, this angle is theta 1, so this also theta 1. Similarly, if we take this angle as a theta 2, then this also will become equal to theta 2. So if we take this. Now from this triangle here, it's a right angle triangle. So here tan theta 1 is equal to 1 by 2. So that sin theta 1 is equal to 1 by root 5, and cos theta 1 is equal to 2 by root 5. Similarly here, tan theta 2 from this right angle here, tan theta 2 is equal to, this is 4 by 3, so sin theta 2 is equal to 4 by 5, and cos theta 2 is equal to 3 by 5. Now with this data, now we can solve this problem. Now we know all these angles right now. So drawing this line here. This is the point O, such that these are these two lines are mutually perpendicular. Now let us resolve this force 200 Newton. It is in the first quadrant, so two components are, one is this, other one is this, and since this here this arrow here, the direction of this force 200 Newton is acting away from this point O, so both the components of this 200 Newton force will also act away from this point O. So this is away here, this is also away, and this 200 Newton force is making an angle theta 1 with this component, so it will become cos component. So this is 200 cos theta 1, and other will become 200 sin theta 1. Next, coming to the other force, that is now resolve 120 Newton force. So it is in the second quadrant, so its two components are one is this and other is this, and here also so now here two components are, one is this and other one is this for this 120 Newton force, and 120 Newton force is acting away from this point O, so both the components also must act away from this point O. And here 120 Newton force is making an angle theta 2 with this component, so it will become cos, so that implies this is 120 cos theta 2, and this is 120 sin theta 2. Next, coming to 50 Newton force, this one here, so it is making an angle it is in the third quadrant, so its two components are, one is this, other is this, so and direction is away from this point O, so both the component directions also away, this also away here, and this force is making an angle 60 with this component, it will become cos component, so that implies here this is 50, this angle is 60, so 50 cos 60, and this is 50 sin 60. Now coming to 100 Newton force, it is making angle 40 with this one, so it is in the fourth quadrant, so both the components are, one is this, other is this, and direction is away from this point O, so both the directions of the components also away, and this force is making an angle 40 with this component, it will become cos component. That implies this is now 100 cos 40 and this is 100 sin 40. So we have resolved all the forces acting on the body uh, into the respective rectangular components, that is along x and y axis, which are mutually perpendicular to each other. All the inclined forces are resolved into resolved along x and y axis into two components. So now we can find out the algebraic sum of all the forces acting along x direction, that is, and we can find out the resultant force x component, that is Rx equal to sigma fx. So now Rx is equal to sigma fx. This is equal to, so starting from here, so 50 cos 60 is acting along negative direction, so it is minus 50 cos 60, and this is also minus because negative direction, 120 cos theta 2, and this is positive x direction, so it is plus 200 cos theta 1, and here also plus 100 sin 40. So substituting these values here, what we get here is so this value we got, this is equal to 146.16, these are in Newton, so Rx. Similarly, next Ry is equal to sigma Fy, and that is equal to, here 120 is acting positive y direction, so plus 120 sin theta 2, then plus 200 sin theta 1, and this is minus because acting negative y direction, downward means negative y direction, so minus, so minus f sin 60 and minus 100 cos 40. So this value is equal to, so this value is equal to 65.54 Newton. And now Rx Ry, we can find out now magnitude of the R, that is equal to under root Rx square plus Ry square, and that is equal to this value is equal to 160.18 Newton. Now let us find the direction. So here we got Rx is equal to positive value, that is 146.16, means it is acting this direction. This is Rx. And Ry we got 65.54, it is also positive, means acting along positive y direction. So this is Ry. This implies that your R should be acting in this direction according to the triangle law. And if we take this, if you measure, maybe this time I will take this angle. So let us say this is some pi. Then tan pi, you may take this angle or this angle. Tan pi is equal to, now construct this triangle here. Tan pi is equal to this by this. This is Rx, so this is Rx by Ry. Rx by Ry. So from this, what we get here, pi is equal to, so we got now pi is equal to 65.85. So finally the magnitude of the resultant of this system of forces is equal to 160.18 Newton, and that resultant force is making an angle 65.85 degree with this vertical axis. Or you may say that the resultant force is making an angle remaining is some 24.15 with the horizontal axis. Both are correct. You may mention with respect to y-axis or with respect to the horizontal or x-axis. Okay, we'll stop here. We'll discuss the problems next.